Exercise 2 of selected set 4, betting your wealth. Suppose now that you're an expected utility maximizer with a utility function, which is a natural logarithm of your final wealth. Your initial wealth is W0, and you can bet X on a lottery that will return you double the amount that you bet if you win, or half of the amount with equal probabilities. So in A, we need to find the optimal choice of X as a function of our initial wealth W0. And in B, we need to show that the elasticity of the optimal choice of X with respect to the initial wealth W0 is equal to 1. Okay, so let's get started. What is the problem that we consider? We need to find the algebraic expression for the optimal choice as a function of W0, and the situation is as follows. If we bet X, then with probability 1/2 our final wealth will be initial wealth minus the amount that we bet, and we get returned twice the amount that we bet. So the final wealth will be W0 plus X. It may also happen, also with probability 1/2, that we get returned half of the amount that we bet. So in that instance, our final wealth will be W0 minus the amount that we bet. We get returned half of the amount that we bet. So our final wealth will be W0 minus 1/2 X. So our expected utility, if we bet X, is equal to 1/2 the cases we get a final wealth of W0 plus X, and the other half of the cases we get W0 minus 1/2 X. That's our expected utility function. Once you reach this point, it's easy, because now we take the first order condition of our expected utility with respect to X in order to find the optimal amount to bet. So we take the first order conditions by taking the derivative of the first part with respect to X, which is this function over here, and we take the derivative of the second part of the expected utility, which gives us the expression over here. Don't forget that here we have a minus sign, so here we also have a minus sign. And then we can just fiddle around with this a little bit, so we can simplify. So you can see that here we have 1/2 and here we have 1/2. On the right hand side we have 0, so we could multiply both the left hand side and the right hand side by 2 in order to get rid of the 1/2. Then we can bring this to the right hand side and swap around the denominators in order to arrive at this expression over here. Well, dividing by 1/2 is identical to multiplying with the inverse, so multiplying by 2. So that is what gives us the expression over here. And this simplifies to 2 times W minus X. And if we then solve for X, we get that X is 1/2 of our initial wealth. So if we face this lottery, we will find it optimal to bet 1/2 of our initial wealth. And that completes exercise A. Then exercise B. Show that the elasticity of our optimal choice of X with respect to initial wealth is equal to 1. So we just take the definition of such an elasticity, which is identical to this expression. So it's the percentage change in the optimal choice of X if our initial wealth changes by X%, and we need to show that this is equal to 1. So we need to take the derivative of our optimal bet as a function of W0. Now we derived that that function is equal to W0 over 1/2. Taking the derivative of this expression with respect to W0 is equal to 1/2. This is what we get here. We also know that our optimal bet is 1/2 of our initial wealth, so we plug it in here. And we simplify the W0s, they cancel out, and we get that this is identical to 1. So this means that if our initial wealth increases by 1%, then we also will find it optimal to increase our bet by 1%. And the intuition is that here we have the natural logarithm as a utility function, and that's a function that is characterized by constant relative risk aversion. So if our wealth doubles, we are also willing to double our bet. And we can see this. So from the lecture you have the definition of relative risk aversion, which is the negative of our wealth times the second derivative of the utility function with respect to wealth divided by the first derivative. And if you take the second derivative, you get this expression. The first derivative of the natural logarithm is 1 over w. So we get that our rate of relative risk aversion is constant and equal to 1 in this case. So this implies that the fraction of our income or initial wealth that we allocate to the risky asset, in this case the bet, is independent of our initial wealth. So, and it's not the amount that we allocate to the risky asset, but a fraction of our income that we allocate to the risky asset. And that is constant, so the absolute amount of the bet that we choose is proportional to our initial wealth. And that completes exercise 2.